my name is Arusa Ishfaq and I am student of MPhil at University of Management and Technology, Sialkot campus. And today my topic of presentation is Fourier transform infrared spectroscopy, abbreviated as FTIR. So first of all, I would like to describe its principle. FTIR is an analytical technique used to identify organic polymeric compounds and inorganic materials as well. FTIR is basically a technique in which we study the interaction of infrared light, with our sample at different wavelength, like broad spectrum wavelength. So the core principle is based on the fact that molecular molecular bonds vibrate at characteristic frequencies, because the reason is why we are dealing with the vibrations of our molecular bonds, because the IR radiations are not energetic enough to create or to cause the electronic transitions like in case of UV visible spectroscopy. So IR radiations are not energetic enough to create electronic transitions. They only cause vibrations of the molecular bonds when exposed to infrared light, and producing a unique spectral fingerprint that can be used to identify and then, for qualitative analysis and for quantify various materials, just like to provide the quantitative analysis. So the technique FTIR can help us to do the identification and quantification, and in result provide us qualitative and quantitative analysis of various materials. So the next is the instrumentation. Basic difference between FTIR and IR spectroscopy is interferometer. So basically I am going to describe it with the help of diagram. So this is the FTIR instrumentation, in which this region consists of the stationary mirror, means the fixed mirror that cannot be moved or fluctuate from its position, the beam splitter, and the third thing is the movable mirror. So these three components are basically the interferometer components, and this is the basic difference between IR and FTIR. So the instrumentation is basically the infrared source that produces the broad spectrum of infrared light. Then the interferometer, as I described earlier, it consists of basically three major components: the beam splitter, the moving mirror, and the fixed mirror. And the diagram also depicts the beam splitter. Beam splitter is basically split the beam coming from the infrared source to the movable, one part of the beam towards the movable mirror and the other part of the splitted beam towards the stationary mirror. Okay, the next thing is sample holder, detector, and computer. So first, when the beam is splitted by the beam splitter and passed to the stationary mirror and the movable mirror, you guys can see there are two arrows. This arrow indicates that the beam is transmitted towards the mirror, and this arrow indicates that the beam is reflected back from the mirror towards the beam splitter, and then the same phenomena is repeated from the movable mirror as well. And these two beams, when reflected back from the mirror, combine here to create a destructive interference or constructive interference, and then absorbed by our sample. Our sample will definitely absorb a beam of specific wavelength, as it is the characteristic of the sample to show absorption at some specific wavelength, at that wavelength that resonate with the vibrational frequencies of their bonds. And then this absorbed wavelength is detected by the detector, and then it is interferogram. I mean to say, here is basically the computer use some mathematical operations to produce the interferogram, and then FT transform or FT spectrum is produced. So this is the whole about the instrumentation of FTIR. And as I described earlier, that the basic difference between FTIR and IR is the interferometer. These three components are are implanted in FTIR, while in case of IR only there is no movable mirror, beam splitter, or stationary mirror. So this is all about the instrumentation of FTIR: the source, the interferometer, the sample holder, detector, and computer. The next thing is operation. What we have to do, or what is the operation of the FTIR? So first of all, we do the sample preparation and placed it in the sample holder. The next thing is interferogram generation. Interferogram generation is basically infrared light when passes through the interferometer and creating an interferogram, which is raw data output. And basically for this raw data is then processed by the computer has some mathematical operations of mathematical logarithms implanted in it to convert that interferogram by using Fourier transform series. So basically this is very complex calculations through which we can convert our interferogram by using the Fourier transformation or algorithms, and this is implanted or processed by the computer to convert them into the infrared spectrum, interferogram into infrared spectrum by using the Fourier transformation algorithms. Spectrum analysis, then we definitely at the last we have to do the we have to analyze or identify, quantify the sample components based on the characteristic absorption bands or specific wavelength. The next thing is this is very the core point of the FTIR or the IR molecular absorption, molecular vibrations. So what are the possible types of vibrations that can occur in a molecule after absorbing IR, infrared radiation? Okay, there are basically there are 6 structures, and the first 2 structures are basically the stretching structures, and the last, these 2 are the stretching structures, and this one scissoring, and the bottom 3 structures are the bending structures. I will tell you what is the difference between stretching structures and bending structures. Stretching structures mean that you guys can see only the bond length is changing between the 2 bonded atoms. There is no fluctuation of the bond angle, only the bond length is changing. So this, when the only bond length is changing, there is no fluctuation of bond angle. This type of vibration is called the stretching. There are 2 types of stretching: symmetric and asymmetric. Symmetric meaning the 2 bond length at the same time, both bond length are increasing. You guys can see with the help of these arrows, or they can be compressing the bond length, but both of them are doing the same thing. Either they are elongation, moving toward the elongation, or towards the compression. So both are elongating in this diagram. The next is asymmetric, in which one bond length is increasing and the other bond length is decreasing. So this is antisymmetric or asymmetric. Okay, these are basically the stretching, in which only the bond length are changing. They are either increase in length or decrease in length. In the next 4 diagrams, we will see the bond angle changing. The bond, you guys can see scissoring, just like scissor handles open and close. So if these 2 arrows indicate these 2 atoms, blue atoms, move far away from each other, the bond angle will change. So this is scissoring, the bond angle will change. So this is the bending vibration, and scissoring is the one type of bending vibration. The other thing is rocking, in which this atom moves in this direction and this blue one is moving after it. So in this case also the bond angle changing. This is called rocking. In case of wedging, both blue atoms are moving out of in the same plane. Just imagine that these 2 blue atoms moving towards us. So these are both are moving out of the paper. So basically these are the wedging. And in case of twisting, in case of twisting, one blue atom is moving in the out of the paper direction, and the other one is moving into the direction. Okay, you guys can see that this atom is looking like this atom is far away from this atom, because this atom is moving towards the inward direction, and this atom will move out of the plane. So in both in all these three bottom cases and this scissoring case, the bond angle is changing. So these four are the bending types and they are named according to the specifications. So this is how IR graph look like. You guys can see there are some there this is plotted against the wave number absorption versus wave number. So this is a single bond stretch. When there are single bonds are present in where there are single bonds, these single bond stretching show vibrations, so show absorption lines in these wave number region. And then triple bond, nitrile bonds, carbenes bond show absorption in this region. Then double bond region, then there is a fingerprint region. So you guys can see that there is a dip in the graph. Dip in the graph show that here is some kind of wavelength that is absorbed by the sample, therefore there is a dip in the graph. So there are definitely there are tabular values for all these bonds, that what is the exact wavelength at which carbon double bonded oxygen show absorption, at which wavelength carbon single bond nitrogen show absorption. So these are some fixed tabular values. So you guys can see also that the stretching occur at the higher wave numbers, while bending bending is the case where bond angle changes occur at the lower wave number values. Okay, the next thing is what are the advantages of FTIR. So the FTIR provides us the rapid data collection can be possible by using FTIR. Because why rapid data collection is possible? Because it provides us simultaneous, like at a time, instantaneous measurement of all wavelength. Okay, the next thing is sensitivity. It is highly sensitive, and accuracy can be achieved by using small quantities of or even traces of materials. Versatility, as it is applicable to wide range of samples, like it can be applicable to solid sample, liquid sample, or gaseous sample. It is non-destructive technique. Because it just causes the vibration of the bonded atoms. It does not cause any kind of destruction to the sample. So it is a basically non-destructive technique. It helps, as we have studied earlier, it helps to quantify and identify the substances. So it is basically help us to identify compounds, like qualitative analysis, and determining their concentration mean quantitative analysis as well. Next is the disadvantages. Disadvantages is that it is quite complex, and it requires sophisticated equipment and software for data analysis, and it is it is advanced form of IR spectroscopy. So it has caused some kind of high initial investment for the instrumentation, and sometimes water vapor can interfere with the measurements with the because water molecule can also sometimes show vibrational frequencies in the specific wavelength region. So it can interfere with the measurements. Sample compatibility. Some samples may be difficult to analyze by using FTIR due to their some physical properties and need for specific sample preparation. And thank you for having me.